Okay, so it's good that this seems to be working finally. So let's carry on here. We will do the spaces today. I'll walk you through that. But first, let's finish off these notes here that I started yesterday. If you haven't already done so, I'd like you to watch the video that I already posted through Teams. It's about 10 minutes long, and it covers this. Okay, so just go through that, please. And if you've already done that, then you can go through this video that I'm just about to do. I'm going to do another example here. This time I have a triangle like this, a right angle in the corner, so it's a right angle triangle. And this time I don't know theta, this angle down here, and that's what I'm going to be asked to find. And what do I have here? Well, this time I have, let's say, 5 here and 10 here. Okay, so I have two sides, and I don't know the angle. Now, we've seen questions before where, for example, I have this side, and I don't know the angle. And we did that using the tangent ratio. Right? We said, okay, well, the tangent ratio, the tangent of this angle, whatever it is, has to be this ratio, opposite divided by adjacent, because that's the definition of tangent. And then we figured out what 5/8 was in that case. I'm pulling up my calculator, which I can confirm now you can't see. There's probably a way for me to do that. And I'll figure this out. You know, this will be good if we have other issues with snow days or what have you. So I used the calculator, I got 0.625. And now we're thinking, okay, tangent is a function. A function has an input and an output. Some specific input, some number for theta, when we apply the tangent function, gives us this output. We want to go backwards and say, look, we know what the output is. What is the input that caused it? Okay, and this is where we have the concept of an inverse function. The inverse function tells you, okay, we know the output. What input of the original function had to do that? Okay, so here, tangent would be the function from an input to an output. Tangent inverse is the inverse function that takes any output we have and tells us what input would have given us that. So to find this input, we're going to use the tangent inverse function on our output. Theta equals tangent inverse, not tangent to the -1, tangent inverse of 0.625. Then I can use a calculator. I'm actually going to quickly bring up Desmos. Actually, that's not going to work, so I'll just use a calculator here. 0.625, trigonometry, second tangent inverse, and I get 32.01. Okay, so in that scenario, I've found that theta is 32.01 degrees. And I know that at least, well, one person asked me, and I'm sure a few of you would have liked another example. One person asked me if I could give another example of how to find an angle that's missing if we know two sides using tangent, and here it is. Okay, so hopefully that helps. In this example here, I've got the same kind of scenario, except I do not have the opposite and the adjacent. I have the opposite and the hypotenuse. Okay, so it's really the same procedure because we have a trig function that gives us the ratio of the opposite to the hypotenuse, and that one is called sine. So here I have sine of my input has to equal 5 divided by 10, which I can simplify as 0.5. And same story, I have an input theta. That input is getting me to 0.5. The function is the sine function. This is just like f of x from last unit. What I want is I want to find out what theta gives me 0.5. And to do that, I use the inverse function. So theta is going to be sine inverse of 0.5, which is 30 degrees. That one I've actually memorized, and you'll memorize that too. Not in this course, but in a future math, you'll memorize some special angles like 30 degrees. Okay, so there we are. So this guy right here, theta, is 30 degrees. That's the only possible angle that could go there to give 5 over 10 as the output to the sine function. Okay, no matter how big or small, any similar triangle that has these degrees, no matter how big or small, it'll work like that. Okay, I'd love to ask if there's any questions. This is kind of awkward doing this as a video, but it's the best we have. I hope you guys are all staying warm and cozy and enjoying the snow a little bit. If you do like snow, going out and maybe sledding on a hill, or maybe just like to look at it, or maybe you don't like it at all. I don't know. I actually like it. It's pretty. Don't know if you can hear the wind chimes in the background. It's pretty windy here. Okay, so that is that. Now, we have another ratio that we're given. Let's take another example. Let's suppose we have this triangle. It's a right triangle. I'm drawing it the same every time just because it's easier to learn. But of course, you could have your triangle like this. You could have your triangle like this. You could have all sorts of different scenarios, different orientations of your triangle. I'm going to stick with this orientation for now. So I've got this triangle. Let's say again, I don't know what theta is. I do know that this is, what should we do here? I do know that this is 7, and I do know that this is 10, but I don't know what this angle is. Okay, so we've got that the tangent of theta is the opposite over the adjacent. We've been doing this for a little while now. We also have the sine of theta is the opposite over the hypotenuse. We've been doing that not as long as tangent, but we've been doing that for a little while too. Well, there's a third one called cosine. And the cosine of theta is going to be your adjacent over your hypotenuse. It's the last ratio, right? When you look at a three-sided object, a triangle, there's only 3 possible ratios. This one over this one, this one over this one, or this one over this one. Or you could go the other way around, hypotenuse over opposite. That'd be a different ratio. But yeah, okay, but that's just this one flipped. Okay, and we do actually have a special trig ratio for when this one's flipped, but we're not going to get into that in pre-IB9. Alrighty, so I want to find this angle. I know the adjacent and I know the hypotenuse. So I'm going to use the trig ratio that involves the adjacent and the hypotenuse. That's this one right here. That's cosine. So here we go. I'm going to set up an equation. Cosine of theta equals adjacent over hypotenuse. So cosine of theta equals 7 over 10. I'm going to go directly and put that as 0.7. Now, cosine is a function. It takes angles and maps them onto ratios. Cosine of something gets us to 0.7. That's applying the cosine function. How do I get my output and figure out what input would have given me that? I use the inverse function, and that's programmed into your calculator. So I'm going to use the inverse function on my output to figure out what did the input have to be to get us there as our output of the cosine function. Cosine inverse now of 0.7 will give me my theta. And I'm going to come onto my calculator. And you too should figure out how to do these on a calculator. So I go 0.7 on my calculator. I know it doesn't show up for you, but I am doing it. Trust me. Here I go second. Here I go cosine inverse, and I get 45.573. I'm not too concerned with how many decimal places you put your answers to at the moment. I'll specify in the questions if I want 1 decimal place, 2 decimal places, 3 decimal places, nearest whole, whatever it may be. Okay, so there we are. I've got the value of this theta. So a few notes, and of course, since this is a video, you can also go back and re-watch if there's a particular part you'd like to see me do again. You can just go back and re-watch it. So I've got a few notes here. Note, first of all, you can now choose whichever trig ratio is most helpful for the situation that you have. Okay, I'll just write that down. You can choose the trig or trigonometric ratio that is most helpful in the situation or the context that you have. So that's the first thing. So if you, let's just actually kind of walk through this here. If you are looking for an angle, then you have to see, okay, out of the two sides you know, what are they? If the two sides you know are opposite and adjacent, then you'll use tan. If the two sides you know are opposite and hypotenuse, then you'll use sine. If the two sides you know are adjacent and hypotenuse, then you'll use cosine. Okay? If, on the other hand, you are looking for a side, you know the angle, and you're looking for a side, you think, okay, which side do I already know? I'll just put this in orange over here. Let's suppose I have this one here. I know the angle, 20 degrees, or 30, whatever that says, doesn't really matter. And I would have to know one side. Okay, let's suppose I know this side. And then you have to think, what side am I trying to find? Let's suppose I want to find this side. Then same thing, you think, okay, which side do I know and which side do I want? If you know and want an opposite and an adjacent, then you'll use tangent. That would be this situation here in orange. If you want and know opposite and hypotenuse, then you'd use a sine. And if you want and know adjacent to hypotenuse, you'd use cosine. Okay? So that is good. You can choose the trig ratio that's most helpful for you. Now, some people like to use an acronym to help them memorize them. So my second note is I'm going to say memorize the ratios. Very important. So when I say that, I'm saying, look, I want you to memorize these right here. And there's a mnemonic that's very popular. People like to say it. It's called SOHCAHTOA. S-O-H. I'll put a dot. I like to split it up. C-A-H-T-O-A. SOHCAHTOA. It's kind of catchy, easy to remember. And what it stands for is it says sine, the sine ratio is opposite over hypotenuse. Right? The first letter of each thing there is given. Now, it's actually wrong to just put sine equals because sine is a function. So I should have sine of an angle equals. Cosine of your angle equals adjacent A over hypotenuse H. And the last one, T, tangent of theta equals opposite over adjacent. Okay, so you can memorize it this way, or you can just straight up memorize the ratios. However you want to do it, that's fine, that's up to you, but you do need to do this. This is a very, very popular mnemonic that you'll have teachers, sometimes they'll just say, use SOHCAHTOA without explicitly saying what they actually mean is use the trig ratios, and this is just a mnemonic. Okay, so that's another note. And another note is solve. If somebody asks you to solve a triangle, what that means is they're asking you to find all the missing angles and all the missing sides. So solve a triangle means to find all missing sides and all missing angles. Okay. So that's what solve means. Couple more things. An angle of elevation. An angle of elevation means you are looking straight to the horizon and then you look up to something. Maybe it's an airplane. Maybe it's a hot air balloon. Maybe it's the top of a mountain. I don't know. Maybe it's a street lamp, top of a tree. But you go across and then you look up. That angle, the angle formed by your line of sight when you look across and then your line of sight when you look up, is called an angle of elevation. You will have word problems where they say calculate the angle of elevation, or they'll say the angle of elevation is 17 degrees, blah 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 blah. Okay, so you need to know what that means. That's what it means, angle of elevation. Angle of depression is similar, but kind of the opposite. Angle of depression means you are looking to the horizon and then down. This would be an angle of depression. Okay? So maybe you're on the top of a mountain this time, and you're looking across horizontally and then down to, let's say, maybe a forest fire. Maybe you're a forest warden. You see a forest fire, and the angle of depression is 20 degrees. That's what an angle of depression is. You know, you could have, for example, you're on top of a mountain. The mountain is, I don't know, well, let's call it, let's say Seymour Mountain. So that's about 1,500 meters, roughly, maybe a little less. So you're on the top of Seymour Mountain. You see a fire off in the distance. You measure that your angle of depression is 20 degrees. And then the question is, how far away horizontally is the fire from you? Then you could use trigonometry to solve that. Right? In this situation, what do I have here? Here's the angle I know. So this one here must be my opposite. This one here is my adjacent. I will often label them right on the diagram to help myself out. This one here is the hypotenuse. It's the largest. And to find x, well, I am involving opposite and adjacent. I've memorized that that's tangent. So I have that tangent of 20 degrees is opposite, 1,500, over adjacent, that's x. Tangent of 20, I'm pulling up my calculator. Trigonometry tangent, I get 0.364 equals 1,500 over x. I'm going to multiply both sides by x. That gives me 0.364x equals 1,500. I'm going to divide both sides by 0.364. That gives me x is, let's see here, 1,500 divided by 0.364. I get 4,121 to the nearest whole. Whoops, 4,121. Let me erase that. 121 meters, because it was in meters. So this question that I just came up with says that this length here is 4,121 meters. In other words, 4.121 kilometers. Excuse me, I'm just going to turn that off. And there we are. Okay, so you now have everything you need to do the whole booklet. Now, I'm sure there will be questions along the way. Please send me messages, and maybe I'll make some more videos, or I'll answer to the class as a whole, and that's how we'll do it. But in terms of trigonometry, we are actually you have everything you need to really hit that booklet and work on the questions and practice them. Okay, so I hope this is very helpful, and that's it for now.